If you're watching this video, it's likely you already know structured query language. Anybody who's been around databases over the past 30 years knows something about SQL. So let's see what an advantage this gives you working with Couchbase. We'll jump right in by building, filtering, and indexing a NQL query. So imagine syntax that looks like this. Select star or specific attributes from, well, not a table, but a bucket, where some attribute equals some value. Well, it could be much more involved than this, but you see how a where clause, just as in SQL, filters your results. So imagine a JSON document like you see at the right. And then a query. Select email and billing address from a bucket where email has a particular value and the type is for a particular document type. It's easy to create specific indexes, just as it would be in SQL. So here we're creating an index on the Customer 360 bucket for the email field, but only where the type is customer. Let's see how this might look in real life. So over here in the query workbench, I've got a create index statement on Customer 360 where type is customer. Now, earlier in the course, you created a primary index for Customer 360, which means we could run any query right now, but it wouldn't perform very well. We're going to create an index now by executing this statement to support queries that use the email and customer fields. So we could then have a query that looks like this, as we saw in the slide. Select the email and billing address from Customer 360 for a particular address of a particular type. Execute, and our results come back, in this case, on a rather lightweight machine, in 3.1 milliseconds, specifically this document shape, the email field, and then the nested billing address object, all contained as a single object within an overall array of objects if we had multiple results to this query. You'd find that NQL supports virtually everything that you expect from structured query language, but tuned to the context of working with JSON documents. You can find out a lot more about NQL in our Intro to NQL for SQL People course, free right here online. So how do you put this to work in PHP? Well, you'd use the Couchbase NQL query class, which has a series of static methods beginning with fromString. You pass to this a NQL statement, which may represent one or more queries. Now, it may be that this is a completely ad hoc query, or you might be executing this query repeatedly. If so, you can set this property ad hoc to true, and your query will be optimized for subsequent uses through query planning. If one or more of the queries within your statement draws on a bucket other than the bucket through which you pass this query, you can set cross-bucket to true, in which case the credentials will be pulled from the authenticator. You can pass in positional parameters. You could also use named parameters, whichever approach works best for your coding style. Last, you can set the consistency for this query. Now, by default, it's going to be unbounded, which is the fastest approach. It means that no timestamp is used in the index scan. Or, if you want to ensure that indexing is fully caught up with the timestamp for this query, you can use request plus, in which case the timestamp for this particular query request is used as the lower bound for all statements within the overall query, with read your own write supported if any of the statements modifies the data that's being selected. Alternately, you could use the statement plus parameter, which uses a per statement timestamp as a lower bound for each statement as it's executed. To run a parameterized NQL query, it might look like this. So we have a get route in Slim accepting a parameter, city. And you see that our bucket has a query method that expects a Couchbase NQL query object. Notice that there's an optional flag as to whether you want your JSON back as a string or a PHP array. So we assemble our query, in this case very simple, select star from Customer 360, where, notice the nested city field within billing address within that document, has the value being passed in as the city parameter. This is going to return a query object, and through the named params property of that query object, you pass in an array of key value pairs representing the named parameter. So in this case, I have a named parameter of city, and I'm assigning to it the city argument passed into the route. You then pass this query object to the query method of your bucket, and it's going to give you back a result. In this case, the results are accessed through the rows property. Now, depending on how you set your JSON as array flag, you may or may not need to JSON encode the results here, depending on whether you're working with this data further in PHP as an array, or if you're passing it back as a JSON string to the client. Your mileage will vary as appropriate here. So what have we learned? Well, first, NQL is SQL for JSON. You can learn a lot more about it free here online, but stop and think a moment just how much power you've already got under your fingertips from the SQL skills you've honed over many years. It's just slightly different when working with JSON. We saw how your queries can be indexed for speed, and those indexes can include filters. We saw how you use the Couchbase NQL query object to assemble your queries. It supports a set of static methods like fromString, positional params, and named params. We also mentioned how routine queries being passed through this object can be optimized as prepared statements. We saw how consistency, meaning how tight the index must be before the results are scanned and returned, can be altered on a per query basis. And last, we saw that when the results come back, they're in the rows property of the object returned from the query method on the bucket. In the lab for this lesson, you're going to use NQL to query and retrieve documents by a specified field value rather than by document ID. You'll also be challenged to go back and rewrite the route code for the prior lessons to use NQL instead of direct SDK methods. And then if you really want to get crafty, go in and use the logging that's available in the Slim framework to do some time comparisons between them and understand the trade-offs that you're making with the flexibility of NQL, which is screamingly fast when you index it, and the direct approach of simply getting, removing, replacing, and so on explicit documents. Last off, thank you for taking time to learn more about Couchbase, specifically about using our SDK for PHP.